So we were discussing about the exponential growth and decay modeling. In the last lecture, we have talked about the exponential growth model. We have already discussed about what you mean by the linear growth. We have discussed what you mean by the linear growth, and we have also discussed what you mean by the exponential growth in detail. Then we have considered one population model in which we have calculated that the population at time t is equals to the initial population when the time is being considered as 0. And then if we have a rate at which the population is growing in terms of a decimal, and if we know the time for which the population growth is to be known, then the total population can be calculated. Do you have any question regarding this model? Do you have any question regarding this model?
No, sir.
Now here in this model, here we have a plus sign. If you see that in this model, we have a plus sign. Mind it, whenever the value for r is greater than 0, the function is exponential growth function. And when r is less than 0, the function is same exponential, but now this time it becomes decay. That's a decreasing. So remember this equation. I will use the same equation. In spite of this plus sign, I will consider a negative sign. By using this plus sign function here, this is the plus sign function. If the initial population was 3,000 and the annual growth rate is 8%, if we convert the 8% into the fractions, that will be 0.08. And as per the numerical, what will be the population in 2027? And the initial year is 1917. So the difference between the years is 110. So we consider time as 110 years. If we place the time as 110 years over here, the value for r, the growth rate is 0.01, and this one will be plus in it, so it becomes 1.08 as in total. And we take a power for that 110 and multiply with the 3,000, we have a very larger number. The total population is 14.25 million people. Now mind it, here we have used a plus sign in the same model. Let's move to the second part for this presentation is exponential decay. When we call about the growth, so this is, we have a x-axis and this is, we have a y-axis. In y-axis, we have a population, and on x-axis, we have a time. If you look into this blue color curve, which is drawn on the graph, here you can see that as the time is increasing from 1, 0, 1, 2, 3, you can see that the population is decreasing. So the decay model is that model in which with the passage of a time or with the passage of a horizontal axis, the vertical axis decreases. Now let's consider the same equation. Now this is the same equation for the population, but here you can note that we have a negative sign. This negative sign indicates that it's a decay. decline. In this, as the time increases, the population decreases beyond the initial population. Now let's talk about the exponential decay problem, one of the numerical. Let's say that the initial population of the bacteria, this time we have considered the bacteria, not the humans, we consider the bacteria. The initial population of bacteria in a wastewater was found as 10 million. So the P naught is 10 million. The aerobic treatment was given to the wastewater to diminish the bacteria in order to kill the bacteria, to reduce the bacteria. We have used aerobic treatment, that we have supplied the oxygen or the air. And the rate at which it is decreasing is very much quicker, as a 2.5%. And the time say that what will be the population after 5 days. So in this numerical, we say that P naught is 10 million. So we have a 10 and 10 power 6. So this is the initial population for the bacteria. This one is for the formula, this negative sign. And if we convert the 2.5% into the fraction, we have to divide 2.5 with the 100. So the answer becomes a 0.25. 1 minus 2.5, it will be a lower than a 1. If we consider power to that, this will decreases. This will have a shorter value as compared to the previous one. So the total population which is available at the initial stage when the time is 0 is 10 million, now decreases to 8.81 million. Yes, do you have any question? Did you understand that?
Sure.
So what is the difference between the growth and decay model? We have used the same equation. What is the major difference in the equation in the model? What is the major difference? This is the decay model.
साइन
No,
का
no.
डिफरेंस है आंसर, यहाँ पे कांस्टेंट नहीं है के।
अच्छा, के तो हमने वो लिया ही नहीं ना, हमने कहा कि एक हमारे पास ये वाला मॉडल है। एक ये वाला मॉडल है पॉपुलेशन का, ह्यूमन पॉपुलेशन का। इन दिस ह्यूमन पॉपुलेशन मॉडल we have a plus sign over here. This plus sign indicates that this is the growth model, यानी पॉपुलेशन बढ़ेगी। अब सेम मॉडल ये यूज होगा। look at that model, p of t equals to p naught 1 plus r power t. Same model use होगा, but this time we have a negative sign. Here you can see that the model is exactly same, except we have here we have a negative sign. This negative sign shows that the model will decay, decreases. इसमें k वाला नहीं है, यहाँ पे है growth rate r. Yes, is it clear?
Okay, sir.
K वाला जो problem था वो ये वाला था, in which we consider that we have a bacterial population, the total n equals to 250 exponential power k into t, that we have discussed in the last lecture. Now this is the equation number 1. I said that, okay, mark it as equation number 1. Now, considering this equation, we have one initial condition given. कि time 10 घंटे, 10 घंटों के टाइम के बाद the bacterial population, now this is the initial population, 250 is the initial population. Bacterial population is increased to 280. अब ये कह रहा है कि estimate the time when the bacteria becomes double, यानी n जो है वो 500 हो जाए. So if we look into this equation number 1, in this equation number 1, we have three unknowns. N is unknown, K is unknown, T is unknown. The three unknowns are there. Here the K is a growth rate. T is the time and N is the number of population. But as we have given the initial initial condition, initial condition क्या है, एक bound condition की दी हुई है that when the time is 10 hours, then the population is 280. So in this model, equation number 1, where the n is there, we will put 280. And when the t is there, we will put 10. So remaining will be the value for the k. By this, we can find out the value for a k. So here we have put it the value for n is 280 and t is 10. And after using the natural log to the both sides, this exponential and log will cancel. And finally, we get a value for the k as 0.0113329. This is the value for a k. So now, previously we have equation number 1 over here. You can see that this is equation number 1. N equals to 250 exponential power k into t. But now we know the value for the k. So the model is updated. And mark this equation as equation number 2. This equation number 2 has only two variables, n and t. Two variables are there only. This is also expressed in this infographics that n equals to 250 exponential power k into t. So bacteria are available into the petri dish. After 10 hours, the bacterial population increases. How much increase? It becomes 280. So if we do the calculation, we will get the value for a k. That's k equals to 0.0113329. So we have an updated model. By using this model, we can estimate the time when the population is double. So in order to calculate the population is double, in spite of n, we will write 500. In spite of n, we will write 500. And 500 equals to, that's a 250 exponential power. There's a value for a k is 0.0113329 and a t. So if we find out the value for a t, it is approximately 61 hours. Is it okay? Now here you can note down as a short formula. Here you can note down a short formula. To directly find out the value for a k. Is this equation is visible to you? K equals to ln n upon n naught divided by t. Have you noted this equation? To directly calculate the k, when you have the new population, the initial population, and the time is given. If you have three these parameters given, you can directly calculate the value for a k without going to the further manipulation of equation. Have you noted this equation? Yes, do you have any question? And then I got 2 messages. Two chats. Please use your mic because um, it's difficult to see the comments during the lecture as compared to the voice. So if you have any question during the lecture, you can ask a question and contribute into the lecture. Yes, do you have any question? I will move forward. Yes, do you have any question or I will move forward.
No, sir.
जी जी पूछें पूछें मुझे समझ में नहीं आया
ये पहले किया हुआ है सब वही नहीं कर पाया था ये काफी अच्छे तरीके से आते हैं
ठीक है कुछ और पूछना है
हाँ सर
Now this is one of the sketch. Here you can see that we have several bacteria are there. This is a representation of a same example. Like we have some wastewater. Through the sparger, we are providing some air to it. So this is the model equation P equals to P naught 1 minus R power T. This minus show that this is the discrete decade formula. And the rate of decay is 2.5, so it becomes 0.025, and aerobic treatment is being carried out. And here you can see that the bacteria are too much on the left hand side as we have provided the treatment of as an aeration. So what is happening to the bacteria? Are they are increasing or decreasing? From left to right, what is happening to the bacteria? Are they are decreasing or increasing?
Decreasing.
Decreasing. This is because of this negative sign available over here. If I only change this negative sign to the positive sign, then the model becomes a exponential growth model. So as we are treating over here the bacteria, so bacteria will diminishes. Consider another example regarding the atmospheric pressure. Let's say we have one model available, P of H. Here the P represents the pressure, H is the height. P of H equals to 1035. What do you mean by 1035? Considering the previous example, if you consider the previous, हाँ जी जी बताएं 1035 क्या है? जिस तरह प्रीवियस मॉडल में यहाँ पे कुछ रीडिंग लिखी थी तो उसको मैंने कुछ नाम दे दिया था. So what do you call it? 1035. What is 1035? इट्स 1035
पॉपुलेशन
नहीं, हाँ इनिशियल पॉपुलेशन यहाँ पे है प्रेशर, ठीक है, आपने ऐसे सही किया कि इनिशियल पॉपुलेशन, यहाँ पे पॉपुलेशन नहीं है, वी हैव अ प्रेशर. So atmosphere pressure, the standard atmosphere pressure at the sea level is 1035 grams per centimeter square. So this is the initial pressure or the pressure at the ground level. Now as we move upward, so the height increases. As the height increases, the pressure decreases. So if you look into this model, does this model contains a negative sign? इसके बाद negative sign है. इस मॉडल में नेगेटिव साइन है, यहाँ पे है ना नेगेटिव साइन.
जी सर
This negative sign shows that the value for the k is less than 1. That means this model is opposite to the growth. It's a decay model. So what we are required, we have given the model. This is a model in which we have a pressure as a function of a height. We can calculate the pressure at the varying heights. And in this equation, we only have two parameters, pressure and the height. Let's say the first we are being asked that what will be the atmosphere pressure at 40 kilometer height. So what will be the value for the H at the first instance? हाइट कितनी होगी, H की वैल्यू कितनी रखेंगे फॉर द सेम मॉडल? In spite of H over here, we will place the value for the H, यानी 40 किलोमीटर ऊपर value. So if I place the H as 40 and find out the answer is 8.5 grams per centimeter square. So now tell me that as the height increases, what happens to the pressure? Increases or decreases? Yes. As the height increases, what happens to the pressure? It increase or decrease? Initial pressure is 1035. Yes.
इंक्रीज हो जाएगा
क्या होगा?
इंक्रीज हो जाएगा प्रेशर
Decrease हो जाएगा, decrease हो जाएगा, because here we have a negative sign. अगर सेम मॉडल को कैलकुलेट करते हुए यहाँ पे अगर नेगेटिव साइन ना दें, इसे आप पॉजिटिव कर लें, तो ये फिर इंक्रीज हो जाएगा. But here you can witnessing that pressure at the 40 kilometer height is decreased from 1035 1035 से सिर्फ 8.5 रह गया. So we have a considerable drop. The second part is your homework. The second part is your homework. It is already solved, available in the presentation. You go through to solve this, and if you have any query, then we discuss in the next lecture, inshallah. Here you can see that this is the graphical representation of a numerical. That's the sea level. At the sea level, we have this model available. And this is the altitude for 40 kilometer. At 40 kilometer, the pressure reduces to 8.5 gram per centimeter square. The second part is also solved over here. You go through this, and we will discuss in the class if you have any query. Okay, did you understand that? Did you got the classwork, homework, sorry? सॉल्व हो जाएगा दूसरा पार्ट?
Yes, sir.
Okay, now let's consider the bacterial growth in a batch reactor. In a batch reactor, batch system, how the bacterial life will be there. So have you saw such a figure earlier? Have you saw such a diagram earlier in any subject? ये डायग्राम आपने पहले कभी देखा है? Regarding the bacterial growth?
Yes, sir. Microbiology में देखा था.
So this is the basic and popular diagram. अच्छा, is this diagram is a growth diagram or a decay diagram? इसमें growth हो रही है या decay हो रहा है?
ग्रोथ भी हो रही है एक टाइम के बाद फिर हो रहा है.
ग्रोथ भी हो रही है और डिके भी हो रहा है, दोनों हो रहे हैं.
Yes, sir.
Now here let me explain it first. What we see, we have 4 phases are there. If the bacteria are enclosed in a one container, then its life has 4 phases. Phase 1, phase 2, phase 3, phase 4. The first phase is called a lag phase. The second phase is called exponential phase, also called as a log phase. Logarithmic increase is being carried out over here. The third phase is called as a stationary phase. And the fourth phase is called the death phase. In the first phase, the cell adapts the environment. And preparing for the division, there will be no significant increase in the cell numbers. So this time period is mostly small. The lag phase period is mostly small. Bacteria adopts the atmosphere and prepare for the growth, but there is no significant growth is there. Afterwards, in the second phase, the bacterial population increases exponentially. That's why it is also called as the exponential phase. In this, the cell is divided at the maximum constant rate, and at this state, we have nutrients abundant. Maximum nutrients are available because this is the start of a process. And the growth rate is exponential. After some time, the third phase is started. We call it stationary phase because at this, the rate of growth and the rate of death of a bacteria, both are same. As both are same, so there will be no considerable increase in the population of a bacteria. Moreover, here the essential nutrients depleted. In the second phase, we have abundant of nutrients. Now the nutrients depleted. And also, there might be a toxic waste accumulated into this space. And as it is a batch reactor, we don't have much space available, extra space available. So the space is limited. So the bacteria are under stress. After some stationary period, we have a fourth phase. This fourth phase, we call it a death phase because the nutrients are diminished. We have extreme nutrient depletion and the toxic levels is high. and the growth, this will causes the a very slower growth rate, whereas the death rate increases. This will cause the decay of a bacteria. Here you can see that we have 4 phases. The first phase is a stationary straight line. Similarly, the third phase is also stationary. The second phase is exponential growth, and the fourth phase is exponential decay. So we have a decay, growth, and stationary phase all together in a one curve. Is it clear? Do you have any question regarding this diagram?
No, sir.
Let's start developing a model. मॉडल कौन सा? पॉपुलेशन ग्रोथ या डिके का पॉपुलेशन का मॉडल. Previously I have shown you the models. Now let's learn how this model is created. ये जो मॉडल है ना, ये जो शुरू में हमने सीखा, ये वाला मॉडल n वाला, ये मॉडल आपने सीखा ना, n equals to 250 exponential power kt. We have used this model. ठीक है ना, ये मॉडल समझ में आ गया था आपको? ये मॉडल आपको समझ में आ गया पॉपुलेशन का?
सर एक बार रिपीट कर देंगे?
नहीं, ये सिर्फ कैलकुलेशन के हद तक था, यहां पे हमने इसको ड्राइव नहीं किया था. n equals to 250 exponential power kt. तो शुरू वाले स्टेज में हमने n की वैल्यू रखनी है 280 और टाइम रखना है 10. इस इक्वेशन में टाइम की वैल्यू रखनी है 10 और n की वैल्यू रखनी है 280. तो इस तरह k की वैल्यू फाइंड हो जाएगी. अब k की वैल्यू फाइंड हो गई तो इस इक्वेशन में हम k की वैल्यू रख सकते हैं. तो नया मॉडल आ गया. इस नए मॉडल में अगर मैं आपको कहूं कि पॉपुलेशन डबल हो गई है, यानी पॉपुलेशन n हो गई है 500, तो आप टाइम बता दें तो यू कैन कैलकुलेट द टाइम. इसी तरह ये पार्ट है इस इक्वेशन में, इस इन्फो डायग्राम में एक शॉर्ट इक्वेशन लिखी हुई है. अगर आपके पास टोटल पॉपुलेशन है, इनिशियल पॉपुलेशन है और टाइम है, 3 चीजें हैं, तो डायरेक्टली इस इक्वेशन से कहता है यू कैन कैलकुलेट द ग्रोथ रेट. यानी n की वैल्यू होगी 500, n नॉट होगा 250, दैट्स ln फंक्शन डिवाइडेड बाय द टाइम. और इसी तरह इफ यू वांट टू कैलकुलेट द टाइम in the case available you can in reciprocate both of them. तो ये आ गया मॉडल. अब लेट कंसीडर ये मॉडल बना कैसे? एनी आइडिया? आपको कुछ आइडिया है ये मॉडल बना कैसे?
नो सर.
अच्छा चले, मॉडल के हमने 2 किस्म पढ़ी थी, इंपेरिकल और मैथमेटिकल. तो ये मॉडल इंपेरिकल है या मैथमेटिकल है? कैन यू गेस?
मैथमेटिकल आई थिंक.
मैथमेटिकल. वो कैसे? तुक्का लगाया?
इक्वेशन से बनाए ना.
अभी हमने बनाया तो नहीं है. हाउ यू गेस करेक्टली? अब हम ये मॉडल बनाने सीखेंगे. तो मॉडल असल में बना कैसे? सो दिस इज कॉल्ड डेवलपमेंट ऑफ अ मॉडल. प्रीवियसली वी हैव डेवलप फर्स्ट मॉडल जो सर्कमफ्रेंस वाला था. लेट कंसीडर डेवलपिंग अ मोस्ट इंपॉर्टेंट मॉडल फॉर दिस एंटायर सब्जेक्ट, पॉपुलेशन ग्रोथ या डिके का मॉडल. So we have a law of natural growth. एक law है. This law is called law of natural growth. Now let's consider that P is a population. क्या है P का क्या मतलब है?
Population.
Population. अच्छा, what this D represents?
Difference.
So derivative.
Difference यानी change. इससे हम यूं पढ़ेंगे, चेंज इन पॉपुलेशन. किस तरह पढ़ेंगे? डीपी मतलब चेंज इन पॉपुलेशन. पढ़ना इस तरह लिखना इस तरह है. डीपी पढ़ेंगे किस तरह? चेंज इन पॉपुलेशन ओवर डिवाइड बाय, नीचे क्या लिखा है? डीटी. इसका क्या मतलब हुआ?
Change of time.
चेंज ऑफ टाइम. यानी चेंज ऑफ पॉपुलेशन पर यूनिट चेंज ऑफ टाइम. यानी पॉपुलेशन चेंज होगी, कितनी चेंज होगी? जब टाइम चेंज होगा. सो व्हाट दिस सिंबल इज कॉल्ड? Sign of proportionality. Sign of proportionality. You guess it right. So the change of population with respect to the time is directly proportional to the population itself. This is called the law of natural growth. One of the simplest model of a population growth is based on the assumption that the population grows at the rate of a population to the size of a population, and this is called a law of natural growth. अब इसको समझने के लिए, लॉ ऑफ नेचुरल ग्रोथ को समझने के लिए, लेट कंसीडर द टू पेट्री डिशेस. हैव यू सॉ द पेट्री डिश इन द माइक्रोबायोलॉजी लैब?
Yes, sir.
तो पेट्री डिश का क्या काम होता है?
Culture grow करना.
Culture grow करना. We have some bacterial population and we provide the food into in an open container, but it has a limited space available. Let's say that time is 0 hour. यानी अभी हमने कैलकुलेशन स्टार्ट की है और एक पेट्री डिश ले ली. इनिशियली द बैक्टीरियल पॉपुलेशन इन दिस पेट्री डिश इज 1000. टाइम कितना है? 0 hour. Let's say after 1 hour there will be an increase in a bacteria. कितने बैक्टीरिया इंक्रीज हो गए? 300. So the total population from 1000 it becomes now 1300 after 1 hour. ठीक है. Now let's consider, अगर मैं शुरू में बजाय एक पेट्री डिश के, if I place a 2 dishes, dish number 1, dish number 2, दोनों में initial population is 1000, same atmosphere, same culture. After 1 hour, what will be the population at the first petri dish? 1300. और दूसरी पेट्री डिश में कितना होगा? 300. तो मतलब सेम टाइप की ग्रोथ होगी. ग्रोथ सेम है. अच्छा, अगर इसकी जगह मैं एक बड़ी पेट्री डिश लेता और उसमें इनिशियल पॉपुलेशन 2000 रखता, सेम कंडीशंस होती, टेस्ट एटमॉस्फेयर कंडीशन सेम और फूड की कंडीशन में सेम. अगर पॉपुलेशन 3 यानी पहले थी 1000, अब है पॉपुलेशन, इनिशियल पॉपुलेशन 2000, व्हाट विल हैपन टू द ग्रोथ? ग्रोथ 300 होगी या 600 होगी?
डबल होगी, 600.
डबल हो जाएगी. डबल क्यों होगी?
350 भी हो सकती है.
क्वांटिटी
300 भी हो सकती है.
क्वांटिटी डबल है.
देखें, ये पेट्री डिश छोटी थी, इसमें 1000 मैंने ऐड किया, तो दोनों में पॉपुलेशन इंक्रीज अप्रोक्सीमेटली 300 आई. इफ आई इंक्रीज द साइज ऑफ अ पेट्री डिश और इनिशियल पॉपुलेशन डबल कर दी और फुड भी डबल कर दिया, एटमॉस्फेयर बिल्कुल सेम है, तो ग्रोथ तो बढ़ेगी ना. 300 कैसे होगी? 300 से तो ज्यादा होगी. कितनी होगी? 300 या 600?
600
मोस्ट प्रोबेबली 600. आप इसे यूं भी कंसीडर कर सकते हैं, वी हैव अ वन सिटी इन अनदर सिटी. दो शहर हैं अलग अलग, इसकी पॉपुलेशन है 1000 पीपल एंड दूसरे शहर की पॉपुलेशन है या किसी विलेज की पॉपुलेशन है 1000. आफ्टर सम टाइम द पॉपुलेशन इंक्रीजेस, इस विलेज की पॉपुलेशन अलग से इंक्रीज होगी, इसकी अलग से इंक्रीज होगी. इफ वी हैव अ larger village where we have more people are there, the population increase will be higher, but the rate remains same. Population का जो rate है, the rate remains same. This shows that we have a higher population, higher will be the growth. The law of natural growth say that change in a population with respect to the time is directly proportional to the population. यानी जितनी ज्यादा पॉपुलेशन होगी, ग्रोथ भी इतनी ज्यादा होगी. ये बात सही है?
Yes, sir.
Now, if I remove the proportionality sign, here I will place equals to the k. K is the proportionality constant. Now, we don't know about the proportionality constant. The proportionality constant is not same for all the activities. For human population, for bacterial population, for the different condition, the population, the value for a k does not remain same. But it's a simplest formula, simplest model, simplest equation is related with the population growth. So this is the equation number 1. Congratulations, you have learned the development of a model. The first simple model related with the subject which is highly developed, highly used in this subject. Now equation number 1 is a simple equation or a differential equation. This equation number 1 is a simple equation or differential equation.
सारा differential equation होगी.
Differential equation, it has a derivative. So we have to get rid of that
Yes.
derivative. We have to solve the derivative. And the technique that we use is a variable separable method. So here you can see that P is on the right hand side. If I shift the P towards the left hand side, so it becomes 1 over P. And if I shift dt on the right hand side, so on the right hand side we have a k dt. As here you can see that k dt and 1 over p dp. Let's consider the integration of both sides. This method is called variable separable method. We have separated all the p terms on the left hand side and all the t terms on the right hand side, and we start integration. So if we integrate 1 over x dx, that is ln x. So here we have a variable as a p, so we can consider ln p. On the left hand side, we have answer as ln p, and on the right hand side, k is a constant value, and we have only a subscript 1 dt. So for this one, we have a t. So kt will be the integration for the right hand side. As in a plus sign, we say that we may have a constant over here, the constant for the proportionality. So that's a solution. In order to get rid of this ln, shift the ln towards the right side. So right side becomes exponential power kt plus c. The exponential has two terms which are on a exponential power is of a two terms, both are being plus. So we can also manage it exponential power c and exponential power k into t. अब एक्सपोनेंट के पावर कोई कांस्टेंट हो तो अगेन कोई कांस्टेंट ही आ जाएगा. So let mark e exponential power c as an another constant a. Let a is the arbitrary constant whose value is exponential power c. अब प्लस हो या माइनस हो इससे कोई फर्क नहीं पड़ता. So let's consider this is equation number 2. अब इक्वेशन नंबर 2 में a की वैल्यू क्या है? इक्वेशन नंबर 2 में a की वैल्यू क्या है?
p power
या
c sir.
हाँ, a की वैल्यू खबर ना है. Similarly, if you solve the differential equation, तो we have to find out the value for the c. कांस्टेंट की वैल्यू फाइंड करनी होती है. तो मेथड क्या इस्तेमाल करते हैं कांस्टेंट की वैल्यू फाइंड करने के लिए? एनी आइडिया?
सर
सर
सपोज करते
कांस्टेंट
हैं
किया है.
सपोज करते हैं कांस्टेंट की वैल्यू.
नहीं, सपोज नहीं करते, हम इनिशियल कंडीशन ऐड करते हैं. हम यहाँ पे कंडीशन ऐड करेंगे जब टाइम 0 था तो पॉपुलेशन कितनी थी? पॉपुलेशन थी पी नॉट. यानी जो प्रीवियस इक्वेशन है, इन दिस इक्वेशन टाइम की जगह आपने क्या रखना है? 0. और पॉपुलेशन की जगह क्या रखना है? पी नॉट, इनिशियल पॉपुलेशन. सो एक्सपोनेंशियल, हाँ, हमने हमने इनिशियल कंडीशन रखनी है जब टाइम 0 था तो पॉपुलेशन थी पी नॉट, ये रखना है ना. इफ एक्सपोनेंशियल पावर के इंटू टी, टी की जगह 0 आ जाए तो 0 मल्टीप्लाई बाय के कितना हो जाएगा? टाइम की वैल्यू है 0. 0 और एक्सपोनेंशियल पावर 0 क्या होता है?
1.
1. So now here you can see that exponential power k into 0, this whole term becomes equals to 1. So a equals to p naught. यानी a जो है वो इनिशियल वैल्यू है. a कैन बी रिप्लेस बाय p नॉट. यानी a जो है एक्चुअल में इनिशियल पॉपुलेशन है. सो इस इक्वेशन में a की जगह हम p नॉट रख सकते हैं. दिस इज द एक्सप्लेनेशन फॉर दिस सेम टर्म. p इक्वल्स टू a e पावर kt. t की जगह हमने 0 रखा. So 0 multiplied by the k exponential power 0. Exponential power 0 equals to 1. So on the right hand side we have a value for a. On the left hand side, जब हमने t की वैल्यू 0 रखी, so the population was initial population. यानी जब टाइम 0 था तो पॉपुलेशन थी इन स्टार्ट वाली पॉपुलेशन, तो इसे हम पी नॉट कहेंगे. अब बाकी सारा कुछ कट गया तो फाइनली वी हैव द वैल्यू फॉर a इक्वल्स टू पी नॉट. So equation number 2 में a की जगह we will place p naught. So we obtain the equation number 3. Now this is one of the most important equation, a basic equation on which the several models are being based. This model is called the law of natural growth, in which we have a population as a function of a time equals to the p naught exponential power kt. ये आप इक्वेशन पेज पे लिखें. आप अपने नोटबुक के पेज पे ये लिखें इक्वेशन. पी ऑफ टी इक्वल्स टू पी नॉट एक्सपोनेंशियल पावर के इंटू टी. लिख दिया आपने क्वेश्चन?
Yes, sir.
Now let's move back previous equation. अब आपको समझ में आ रहा है, ये वाली सेम इक्वेशन ही है. यहाँ पे P की जगह N है, 250 इनिशियल पॉपुलेशन थी, एक्सपोनेंशियल पावर KT. सेम ही चीज है, मॉडल सेम है.
Yes, sir.
इसी तरह लेट्स मूव टू अनदर एग्जांपल फॉर प्रेशर वाला जो एग्जांपल है, प्रेशर और हाइट. दिस इज P ऑफ H, उसमें है P ऑफ T, पॉपुलेशन विथ रेस्पेक्ट टू टाइम 1035. यहाँ पे इनिशियल प्रेशर था, और यहाँ पे सिर्फ चेंज क्या है, हाइट, और दूसरा चेंज है नेगेटिव साइन. नेगेटिव साइन शोज कर रही है कि इट्स अ डिके मॉडल. सो इज दिस सेम इक्वेशन?
Kind of, yes, sir.
दोनों इक्वेशन बिल्कुल सेम है, पैरामीटर्स अलग अलग हैं. उसमें बैक्टीरियल पॉपुलेशन है, इस वाले में है बैक्टीरियल पॉपुलेशन, और ये ग्रोथ है बिकॉज के की वैल्यू पॉजिटिव है, और यहाँ पे है बैक्टीरिया. और जो एक्स एक्सिस में पैरामीटर है दैट्स अ टाइम. सेम इक्वेशन यहाँ पे यूज हुई हुई है. यहाँ पे पॉपुलेशन की जगह यहाँ पे है प्रेशर, और टाइम की जगह है हाइट, और नेगेटिव साइन शो कर रही है कि दैट्स अ डिके मॉडल, बिकॉज द वैल्यू फॉर द के ग्रोथ रेट इज नेगेटिव. जब भी ग्रोथ रेट के की वैल्यू नेगेटिव हो दैट्स मीन डिके मॉडल. अगर यहाँ ग्रोथ रेट पॉजिटिव हो दैट मीन्स एक्सपोनेंशियल ग्रोथ मॉडल. ग्रोथ में के की वैल्यू पॉजिटिव होती है, और डिके में के की वैल्यू नेगेटिव होती है. So here you can see that it's written. The constant K is the growth rate H with the population changes. If K is positive, the population increases. If K is negative, it decreases. K, अच्छा K का यूनिट क्या है? पॉपुलेशन ग्रोथ रेट जो है, K का यूनिट क्या है? इस K का यूनिट क्या है?
The K constant.
नहीं, इसका यूनिट होगा ना, कांस्टेंट थोड़ी है. K तो ग्रोथ रेट है, मैंने कल लेक्चर में बताया था. K, the unit for K is reciprocal to the time. If the time unit is hour, then the K is 1 over hour. If the time unit is day, the unit for the K is 1 over day.
Yes, sir.
So this is the infographics. So K is greater than 0, so there will be a growth. If K is less than 0, there will be a decay. This is the differential basic equation. If you solve this equation, you will get the simplified equation is P of T equals to P naught exponential power KT. If you draw this graph, the graph looks like this. इसमें कुछ भी values होंगी. If you draw this graph, you will have an exponential growth like this. Yes, do you have any question? Yes, do you have any question?
Okay.
In the next lecture, we will solve this problem. Find out the value for a K from the data. So we have developed the model, and then we will find out how to effectively utilize that model Inshallah, in next lecture we will discuss it.
Sir, attendance.